to this edition of Orbis Connect. I'm Shaky, not your usual host. We unfortunately haven't got the pretty face of our other host if you've ever been to one of these events before, Joe Davies. So this is a JVM war. Looking back in the comments, we got a nice little stream of comments going already. So looking further back into today's chat, we've asked if it can be called London JVM Pride. Just we kind of really representing the differences between the languages. So what we're looking at the levels of productivity, what features that each of them can offer, and why each of our presenters believe that their language is the better language. I think we've got a good range of panelists today where they come from various different backgrounds. They work with various JVM languages as well, so they kind of know the ins and outs of each of them. So just wanted to introduce you to the platform as a whole if you haven't actually used it before. If you just look right down the bottom of the screen under my face, if you don't want to look at my face, just look at the questions. You've got ask a question, you've got the polls there. So obviously we're trying to see who's going to come out on top now, and actually it's quite interesting to see that we've already got 11 votes for closure, which is taking the lead. So David, who is our Kotlin presenter, is going to have to do some making up. Scala's coming back on. I think I've made people attention to that poll. So please vote away. By the end, we'll see where we've come to. Obviously, we're not going to solve anything by the poll, but it'd be good fun. So yeah, and then what else we got here? So got a good stream of people. Introduce yourself if you're from. I'm from Wales, but I'm in London at the moment. We've had people already in the chat from the US, from Berlin, from Prague. God, I'm not even seeing these until now. San Fran, Brazil. So fantastic. Hey, welcome everyone. Oh, Cameroon. There we go. Africa. I think that's a new one to Orbis Connect. So yeah, as I said, great panel lined up today. What we're going to do is just to keep them on their toes a little bit. There's no order yet. I've got a lovely little presentation to do later, which is a bit weird, but the panel is consisting of, so we got Ben Gamble, he's the head of dev at Ambly, so it's a distributed data streaming network. We'll be fighting the Java corner. We got David Denton, the self-proclaimed refactoring wizard and legacy code cleaner. So he's also the creator of HTTP 4K, a Kotlin web framework, so therefore he's going to be fighting the Kotlin battle in the Kotlin corner. We got John Stevenson with the best job title I've probably ever seen someone give themselves as the Chief Fun Officer of Practicali. And he's also one of the co-hosts of London Clojurians community, so he's got a massive Clojure community out there, so he'll be fighting that corner. And then finally we got Adam Morsky, so he's the CTO and co-founder of Software Mill and an active blogger, so fighting the Scala corner there. Also on this, if you got this on a desktop or something, right at the top by JVM Wars title, you've got an info button. So if you ever want to just find out where these guys have come from, who I am, there's a link to my LinkedIn there. There's a link to people's GitHubs, Twitters, everything that you need that you can have a little browse at later. So stop, no more, introduce some people. Gosh, the chat's going off, it's fantastic. Here we go. So just going to introduce, so I used to be a teacher and I used to absolutely love getting kids up who's going to be speaking first and using my lovely little screen. So up first, so what I'm going to do, I'm going to introduce them as they come. So up first, we have David. Okay, so David's going to be in the Kotlin corner, and I don't know what's just happened there. Okay, so as again, please look at the polls. Any questions she's put in there. If you're also on the LinkedIn chat as well, please for much longer. I'll be back on the screen after you've done your presentation.
Fair enough.
Cheers,
okay.
David.
Okay, so
right,
just bear with me.
Yeah, no, sorry.
Whilst the technology does its magic, hopefully, we'll see what happens. Right. This is going to work. All right. There we go. And here we are. Can you see that? Is that all good? Is that good?
Okay, one second, David. Yeah, I think just getting heads up from my colleague at the moment that you're freezing a little bit, so I'm not sure. Okay, just one second. whole page. The whole page. Refresh the whole page. Yeah. Sorry, David, can you? Yep. Okay. Everyone seems like it's working again.
Should we try? Okay, right. Let's do this then. Okay, here we go. So is that better? Is that working?
Perfect. That's working for me anyway. So
excellent. Well, that's good enough. Okay. Shall I start then? Should I do it?
All yours. Floor's yours. Brilliant. I'm off mute now. I'm being quiet.
Cool. Excellent. Right. Hi everyone. I'm David. I'm going to be representing Kotlin this evening. So first off, who am I, and how come I'm qualified to talk about Kotlin? Well, I've been developing for about 20 years. You can see from this slide, these are the kind of languages I've been using over various times. I've been using Kotlin since 2015, which is before version 1 came out. I've used Kotlin to deliver a load of JVM projects in the back end. I've most recently done a bank, and I've also done a massive academic publishing website. So hopefully I'm kind of got enough experience, hopefully. You can also find me on GitHub. I do a load of open source stuff. I'm currently doing H2FK, which is a web framework, or web library, should I say, in Kotlin. I also have been lucky enough to do some speaking at the Kotlin Conf, which was really good. And I am also a trainer, so I do a Kotlin course for Java developers with my compatriot. So hopefully I'm good enough in terms of experience. Anyway, so let's get on with it. So starting off, so here's a quote from Picasso: "Good artists borrow and great artists steal." The only problem with that is obviously he didn't say it. It was T.S. Eliot, and he didn't actually say that. He actually wrote, "Immature poets imitate, mature poets steal." You can blame Steve Jobs for making that quote up from Picasso. Anyway, so on the same note, I'm going to say the good languages borrow and great languages steal. So what's that got to do with Kotlin? Well, so what Kotlin does is basically take a bunch of really good languages, and it takes a load of really cool features and re-implements in a really pragmatic way to kind of like a mixing pot to actually make a really, really, really nice kind of pragmatic language that's really productive. And I'm going to go over the various kind of things that I love about Kotlin, and I hope you'll love them too. So I hope you encourage you to try them. So here's the big one, null safety. So lots of people know that, on the JVM, the null pointer exceptions are the kind of biggest problem, one of the biggest problems anyway. Not many people know that the null pointer was actually invented by this guy, Sir Tony Hoare, in 1964. He was a programmer who kind of, he got knighthood, so he must have done something right. Anyway, it was his billion-dollar mistake. But anyway, so obviously, if you look here, what we're attempting to do in the bit of code, we're trying to actually assign null to an int value. And then what's going to happen is when we try to call toString, we're going to get a null pointer. Well, in Kotlin, it sidesteps that entirely, basically by building null into the type system. So we're embracing null as a concept. And actually, instead of using options, which you can do in Java and Clojure and in Scala, we actually use null, but null is baked into the type system. What that means is that basically whenever you've got null, you have to dereference it with a question mark. So that basically forces you to deal with null on the spot at every point in your code, which basically sidesteps the entire kind of problem of null pointer exceptions at all, which is absolutely amazing. So yeah. Next thing, extension functions. So extension functions allow you to effectively add extra functionality to types you don't own and types you do in a context-specific way. So if we look at the screen, we've got like there's some text, there's some code which I'm sure everyone's written loads and loads of times, which is to read all of the text from a file. So we've got a read text method, and you can see what we're doing here is actually we're defining a function on file, so all files will get it. And we stick that code in there, and then from then on, every single file object can actually use that thing. That's really handy, and what's even better is that in Kotlin, you don't even need to write the method because it's already built into the standard library, along with like hundreds of other little really useful functions that, for some reason, have never found their way into the standard JDK. Next, sensible conciseness. So Kotlin kind of really promotes a kind of pragmatic view of functional programming and kind of takes a load of default stuff and that's sensible default. So for instance, we get immutability by default, which is great because, you know, you don't get like mutability is bad, and we like to be immutable wherever possible. Next thing it does is type inference. The type inference system is really good, so you don't have to repeat your types all over the place. You get data classes. Data classes allow the compiler to generate equals to code and equals hash code and two-string methods on data structure objects. So all that code just falls away, and you never have to write it. Trailing lambdas. So as well as being a higher order, supporting higher order functions, Kotlin allows you to trailing lambdas. So on the previous page, we had the use method. That was not actually a part of the language. That was actually just an extension function that took a lambda as its last parameter. So it looks like a part of the language, but it's not. Kotlin also supports inference functions and operators, much like Scala, and it does DSLs. There's an interesting little pattern called trailing lambda with receiver, which looks really, really strange, but once you're used to it, it allows you to do some really, really powerful stuff with writing concise DSLs. Next, Kotlin everywhere. So this is kind of a future feature, but it's definitely one to look out for. So Kotlin mostly is on Android and JVM at the moment. That's where it kind of really shines. But JetBrains has this kind of ambition to take Kotlin to every single platform in much the same way as Java kind of once said, write one, runs everywhere. Maybe in Kotlin we'll finally get, in a few years at least, when it's actually ready, the one language to rule them all. So now I'm going to cheat a bit because there's hundreds of other things that are really about Kotlin. It's really easy to learn. The tool support's really good. The standalone is great. The community is amazing. But the most important thing is at the bottom, which is how do developers and maintainers feel about Kotlin? And the good news there is they absolutely love it. And it's basically there's support for Kotlin in pretty much lots of the popular kind of Java open source libraries. You've got stuff like OKHTTP, which is the really popular HTTP client that's actually now completely written in Kotlin. So you're probably using Kotlin in your code base whether you like it or not, depending on. But anyway. So in the interest of balance, I'll tell you like one thing reason you shouldn't use Kotlin. That's basically because you might like it so much that you don't actually want to go back. Anyway, so it's basically, it might just ruin programming for you for good. Anyway, right. That's it. Thank you very much for all your attention. Bye.
Thank you very much, David. Cheers for that. What we're going to do is any questions, again, please ask away. What is just so much easier for us, our end. Sorry, you can't see us. Just to bring you back up.
Oh, yeah.
You're going to say goodbye, next one up, and then we'll have all questions at the end. Some really interesting points there from me as well, obviously, as a non-technical person, so I'll keep them for later on, which is great. And I think we've got a couple of questions coming in, so it's going to keep ticking over. So, hey, awesome. Thank you very much for that. We'll bring you back up at the end. Cheers. Right then, let's get my Wheel of Fortune back up, shall we? If it's still there. If it's not broken, it's completely broken. What has happened there? Let's do a little reset. If not, I might just have to pick them out of the mysterious hat I have on the floor next to me. Here we go. Okay, this is a mysterious hat because the feature wasn't quite working on my spin the wheel for the second time. So I think next time we're going to bring in Adam for Scala. So here we go. It's working perfectly fine. It's typical, isn't it? As soon as you go live. So let me just bring up Adam. There we go. Jan disappeared. Again, just want to, while that's loading up now, just bring your attention towards the questions and the polls again. Well, it seems like Kotlin has brought up some votes there. So done something well, David, and really kind of ruffled some feathers there. I want you to start thinking about maybe if you're looking to learn a language, if you're looking to learn about certain features. Oh, here we go. Yeah, if you're looking to learn about certain features, then please just ask away. And yeah, hey Adam, how are you?
Hello, I'm good.
I think we need to lower the camera and see what that T-shirt's saying. Is it appropriate? There we go. Nice, nice. So yeah, Adam, little brief introduction at the start. Obviously, you're based over in Poland yourself, and yeah, got quite a bit of active blogging on Twitter and some active blogs out there, which again are visible from the information bar at the top if you ever want to check anything out. Do some self-plugging if you want, but let's focus on some features. I'm gonna get you to share your screen now, if that's great.
Yeah, let's see if this
there
works.
we go.
Okay, so let's move this out of the way.
Move that out of the way, and I'm gonna. Seems like we got quite a full screen, so we're gonna take our videos off just so that everyone can see the screens. Okay.
Sure.
Or because that kind of just takes us out of the way and everyone can see what you want to show off. There we go. Work away, Adam. It's all yours.
Okay, thank you. Great presentation about Kotlin. Actually, a lot what was said about Kotlin applies to Scala as well. So some of the productivity tips apply in both languages. So yeah, as I was introduced, my name is Adam Varsky. I come from Warsaw, Poland. I'm the co-founder at Software Mill, and I'm representing today Scala. So Scala, what is it? It's a strongly typed functional programming language. It compiles down to bytecode on the JVM. You can also run it on JavaScript. So it compiles down to JavaScript and to native code. And I think it's currently the best way to do functional programming in a business setting. So Scala has all of the basic features of a functional language. So we have lambdas. It is expression oriented, which is a very important trait, meaning that everything is an expression. And if is an expression, a match, a case, a switch, and so on, these are all expressions. So we have functions as values, methods which can be converted to values. So everything is a value which we can work with in a functional way. We've got data classes, pattern matching, and so on. So these are the basic things, but Scala is much more than that. There's a lot of things that make Scala unique. So you might have heard about type inference, where the compiler is smart enough to infer the type given an expression. So in Scala, we also have term inference, where the compiler can figure out values of types given a type. So these are Scala's implicits. We have higher order types, which make it possible to define really flexible and powerful APIs. Also, Scala is a very regular language, meaning that it doesn't really have a lot of features, but these features are very general. So, and they interact in many interesting ways. They also interact in some non-interesting ways, but as a community, we have learned which combinations are good and which are bad. And finally, it has rich meta programming capabilities, so we can do a lot at compile time instead of doing it at runtime. But jumping to some more specific things. So I guess one of the main powers of Scala lies in domain modeling. So modeling complex business domains is something that we do every day, especially if we have complex problems. We need to spend a lot of time on modeling domains. So in Scala, we have data classes like here. So these data classes are always immutable. We have some fields, as you can see here. So here we have an optional field. In Scala, we don't use nulls at all. And really, null pointer exceptions and nulls are not an issue, because everything, if it's optional, we wrap it in an option. So here we have an example of a simple immutable data class. Here we have an example of a sealed hierarchy of classes. So the hierarchy is sealed, meaning that all of the possibilities, all of the implementations are enumerated in this source file. So if we have a value of type entity, we can be sure that it's either a person or a company, and this will be verified by the compiler. Also, all of the collections, so here we have a list, all of the collections that we use in Scala by default, lists, sets, maps, and so on, they are all immutable. And this brings us to the first, and I think one of the most important productivity gains, is that Scala is an immutability first language. By default, everything is immutable, and this has deep impact on the whole ecosystem, meaning all of the libraries that you are going to be working with will be adapted to working with immutability. So this makes it easier to understand code, but it also makes the code automatically well, in some aspect at least, threat safe. So secondly, Scala allows you to define really flexible APIs. So let's say we have a set of entities and we want to extract the streets corresponding to these entities. So in Scala, we would take the set of streets, and then we have to map those streets into then we have to map those entities into the streets. So here we can have two cases. As I said, this is verified by the compiler. Either it's a person. If it's a person, we take the addresses of the person and convert it to a set in this example. And if it's a company, we create a single element set of the headquarters of the company, right? And we obtain a set of addresses, and then we just have to map this to the names of streets. So this kind of APIs create really concise code, which is easy to understand and easy to read. You don't really need to know a lot of Scala to understand this. Everything is verified by the compiler. The fact that we have covered all of the cases here, this will be verified by the compiler as well. And this brings us to the second productivity gain, which is the ability to write concise, type-safe, and readable code. And this applies the same to simple manipulations on collections as we see here, but this also carries over to manipulating big data sets, for example, in Spark. Okay, going further, let's talk a bit about metaprogramming. So quite often we have to serialize values to JSON and from JSON, for example, right? So here we have an example of how to define a JSON, then an encoder and a decoder in Scala. So in Scala, this is typically done at compile time, meaning that if you want to define a function which takes an address instance and converts it to JSON, we will use a library, which here, this is the Circe library. Note that this is not baked into the language. We are only using some language mechanisms. So this library defines a derived encoder method, which is really a macro. A macro is something that runs at compile time, generates some code, and this code is then translated further to bytecode by the compiler. So this derived encoder method over here, what it will do, it will actually generate code which takes an address, serializes it to JSON, and this code generation of how to convert this will be done at compile time. Same for parsing JSON. So here we have a parser for a validation response class, and this is all generated by the compiler. And if this compiles fine, we can be sure that we are able to encode and decode JSON, right? So this brings us to another productivity gain, is that instead of runtime testing, instead of checking if something works at runtime, we can often instead get a proof at compile time that something is available and will work. Going further, let's look at how would you send an HTTP request in Scala. So here we have a description of an HTTP request. This is a value. So in Scala, very often we create DSLs, which create descriptions of things that we want to do. So here we have a description of how to send an HTTP request to the given URL. And here we are setting the body as an address instance. So this will only compile if the library that we use here will know how to serialize this instance into an HTTP body, right? And this way of specifying how this can be serialized is given here, right? So this will only compile if it is known at compile time how this type can be serialized. So the compiler will actually figure out this reference over here automatically. So so that's how we work. That's how we often work with DSLs in Scala. And this brings us to the next productivity gain, which is like more general, I would say, is that in Scala we very often work with libraries instead of frameworks. So this gives us a lot of flexibility and a lot of liberty into how we can work and define our business code. So the libraries still need to form a cohesive whole. So they need to work together and interact together. But we are not so much constrained, and we don't have to fight this framework as often as in other languages. So finally, summing up why types, like types is the central biggest benefit, I think, of Scala. the whole goal of types is to make illegal states unrepresentable. Computers are really intelligent enough to prove a lot of properties about your code. And while in other languages, you might spend quite a lot of time rerunning tests and so and fixing various silly mistakes, in Scala, this is done by the compiler. It's true that the Scala compiler does take a while to complete and to compile the code, but it takes some time for a reason. It simply needs to verify much more than in other languages. And I think this brings us to the final productivity gain, which is that types give us explorable code and explorable data structures, explorable APIs, both through autocomplete in the IDE and through simply navigating and jumping to definitions. Is a very powerful tool to understand how a code base is structured. So yeah, Scala 3 is coming up. Scala 3 Streamline simplifies and makes a lot of the rough edges of Scala 2 disappear. So take a look at that. And with that, I think that's all that I wanted to say. Thank you very much. And I guess we'll be taking questions at the end. And yeah, I made it in 10 minutes. Thank you.
There we go. Spot on. Thank you very much. To be honest, when you sent, I asked the guys for the presentation beforehand, and when Adam sent it to me, I went, "What is that?" So I'm so glad that's come up, which is fantastic. Seems like it's gone down well in the chat. So hey, conscious of time, I know you were spot on time, but straight on to the next one. Awesome. Thank you very much. And we got some questions coming through.
Thank you.
Cheers, Adam. Have a good day. Right, next up, we're just going to go straight on to the next one now. I think we're going to go back to, we got the polls coming in at the moment, and Scala and Clojure on 16 votes each, Java on 11, and Kotlin on 11. So to give Ben the opportunity to get those Java votes up before John comes in, we're going to get Ben Gamble up next. So again, just a quick reminder of a couple of things that we got going on. Again, we got the polls, we got the questions. Again, if you're on LinkedIn as well, please get your questions in. I will still be able to see them. I'm chatting away. I'm not actually doing what I'm meant to be doing. So, so whilst I'm doing this, give me 2 seconds. I can't multitask very well. Okay, so Ben, you have been invited in. You should be coming up now. I think John's commenting away. I think he's doing a little bit of a battle there, trying to ruffle some feathers. Here he is. Ben's ready to rock and roll. Yes, I can hear you well. Thank you for coming along. It's your time to shine. It seems like we've got some good ones going so far. Now. Here we go.
Can everyone see?
I can see it. Hey Ben, before you start, is there anything that is in the kind of bottom corner that
Nothing whatsoever.
So I'll keep your face up then, okay, this time around. So please work away.
Okay, so because of Java is a bit more ubiquitous than the other three things here, I'm going to focus on a slightly different angle here, because it is Java everywhere, and that's really its superpower. So a bit about me. I'm head of developer relations at Ably. I insist everyone reads the Phoenix project. I do get very excited by cool things, hence I have programmed in all the other languages as well, listed here. And I've spent an ungodly amount of time debugging things like distributed systems, mostly in Java, also in C++, as my background has been a mix of simulations, games, and apps. Let's start a bit with what Java actually was built to be. And this is a direct series of quotes. It must be simple, object-oriented, familiar. It must be robust and secure. Architecture neutral and portable. It must be executed with high performance, and it must be interpreted, threaded, and dynamic. Now, whether or not it actually meets all these has sort of been proven by, it's standing the test of time, as it started, in the mid-90s and is still around today and is enormously popular. Kind of the USPs of Java specifically are explicitness, which is about clarity of intent, right? You have to spell out what you're trying to do in Java. There are less language features than any of the previously mentioned ones, and the next mentioned one. What that really means is you want to do something, you say what you're doing. it's verbose, which kind of promotes debuggability. You can't overload operators. There is not so much hidden control flow. You can't just branch out randomly into a dot operator that actually happens to, call an HTTP request. These things don't happen. And what this also means is that when another developer comes to see your code, the verbosity nearly always means that they can read it and understand it without having to infer what magic you've managed to bake in. This is because, as per always, if you write the code when you're at your smartest, when you come to debug it 3 to 6 months later, you won't understand it, and neither will the 30 other people who have to work with it, right? And the real thing is ubiquity. Java devs are everywhere, right? It's taught at universities at what can only be described as a variable level of quality, but they are everywhere. And you only really pay for the complexity you use with Java, which is that, like everything else, you can just get POJOs everywhere. Plain types with nothing baked in. You want, the equivalent of data in Kotlin is wonderful if that's what you want. But most of the time, you only want one of those functions. And I don't want to end up with something calling a function I haven't fully explicitly written. So you pay for what you use. It's not as good as some languages for this, but it has this kind of thing. But what else though, right? We have Java, but then we have to think about the ecosystem because none of these languages fit in a box. Now, the thing about Java is you get all of these in the other languages, but with Java, you get a little bit more because everything is designed often with Java in mind. Ubiquity has its advantages, and these give you superpowers. The JVM effectively is the superpower for all of us, which is that you can use almost every library you could think of. And there are 18 million reasons currently on Maven Central suggest that this is a good idea. Now, Java itself is everywhere. You've all probably played games written in Java. RuneScape, written in Java. Minecraft, originally written in Java. MatSim, a massive distributed simulation for traffic and things, written in Java. And other things like this. Now, as I said, I'm speaking use case here because you're all familiar with Java code. And, it's less impressive to show off the new features in Java, which, to be honest, are just borrowing back from all of its small children, which is wonderful because, we should all learn from each other. And that's always the thing about Java, is it's that lovely common denominator. At no point can you not call a normal Java function from some jar. It will just work. It will work in Scala, it will work in Clojure, and it will work in Kotlin. And that is wonderful. In the other direction, however, it mostly works. Doesn't always, but mostly. So there are times when it's things like, what is your common denominator? And it's Java. If you write it in Java, everyone can use it. And just about popularity, right? So a quick search in a 10 km radius from where I am, right? In the last 72 hours, there were 150 jobs posted. And I got bored of counting when I got over 150, right? And you can hire for it. We're still at the top of the Toby charts. You know what? At a certain point, programming is a collaborative sport. You win by having teams that can do things. And that is the critical thing with Java. It's all about being able to do it en masse. And that's where the explicit thing is. But just to go into a bit more things, it does everything in DevOps. It does everything serverless. Because all the documentation for all these things, by default, is to Java, because it's everywhere. And to be quite frank, I don't want to do anything without good documentation these days. We've all suffered that one before. So it's really just about taking what sadly is the easy and obvious choice in most cases. And it has some of the bigger and better sponsors. Scala is the thing to use if you're in finance. Clojure is the thing to use if you are at Netflix, bizarrely enough, and if you want to kind of have that kind of lovely adaptability and you like Lisps. And Kotlin is the thing to use on Android, but everywhere else there's Java. It's a bit like the MasterCard ad. And to go back to the USPs, explicitness. You know what you're doing because you've had to write all the code. It's verbose, which means you can debug it. You can put a debugger on any step you want and you will see what happens. It is ubiquitous, which allows you to hire whoever you need, right? Wherever you are, you'll hire Java devs. They'll all understand what you're trying to do. And the complexity is only what you want it to be. Functional programming is brilliant, but I'll be honest, hiring functional programmers is expensive. And often they're smarter than me. So this is the thing. You pay for what complexity you want. And in general, I find that simplicity rules. And I'm sure the Clojure person speaking after me will say simplicity is indeed the right thing. And I agree. But for the things I want, Java is the only answer. Thank you.
Beautiful. I think you've played a little bit to my background, being recruiting. Let's focus on the hiring needs. I'm like,
I think it's
yeah,
right. Like,
I got you.
So I've worked in startups for most of my career, and I've worked doing things for VCs a lot. And the one rule you always run into is if you can't scale a team, you can't build a company. Right? And it's teams that build
directions. I like it. No, it's fantastic, and obviously it's clearly given a good understanding. Like, feels like you're defending it as like a core JVM language.
It is,
and it's great to see how the added features have come on in different languages, and hopefully that will maybe not ruffle a few feathers, but it seems like it got a conversation going. Let's just say that.
So I'm watching the chat because I'm looking at my notes. For
yeah, no, of course.
And the fun thing is, like, it's never been about one language to rule them all. It's all about what you best get.
Yeah. I think I just want to like reiterate, we all kind of met up before, and I was here like as a recruiter being like, oh, let's fight, let's do things aggressively, and you're all like, no, positive chat about everything, and I'm like, damn, but it's all cool. Thank you very much, Ben. Great chat. The light's back on now. It doesn't look like you're ready for bed.
No, literally the sun started setting slightly before I got up here, and then it got really dark, and I didn't realise.
I will let you go. We're going to got some questions ready to go. We'll bring you all back up in, 10 minutes time roughly after John. Thank you very much. Cheers, man. All right then. So, last but not least, there's a bit of fighting chat going on in the chat right now. So, John, it's your time to shine. I'll invite you up on the screen. So I just want to remind you all again of the questions. This is the vital time now where your questions are going to come through. And you've got the poll. So what we got here, we still got Closure. You're going into this ahead. So I hope you can get into the chat now and got your chance to shine, essentially. So I have invited you in, John. So please accept and come in. Otherwise, I'm talking to myself. Unfortunately, I can't fight for Closure because God knows what would come out of my mouth. So, John, you have accepted. Right. Do the old reload. Good old reload, John. Type that message to you, John. If you can just refresh the old screen, see what we can do. Going so smoothly. Yes.
I'm alive.
I did start to sweat a little bit then. You're alive, you're there. Hey, John.
Hello. I'm just trying to work out which is the screen I have to select for sharing.
I would rather share the right screen right now, John.
Oh, that's it. Yay.
I know.
Yeah, I found it.
All right.
Cool.
So, it seems like you've pulled ahead. No, you're still neck and neck. So, if you're down after this vote, I don't know what you said. You said the wrong thing. Just so obviously on practicality as well, you obviously do a lot of YouTubing yourself. You do a lot of public figure stuff and getting your name out there. So yeah, hopefully people love this. I'm sure they will.
Thank you very much.
Floor's yours.
Thank you. What are we talking about now? Oh yes. Can people see my screen? Screen. Yes. Okay. So hopefully you can see my.
You're good. You're ready to go.
Excellent. So Closure. I've titled this "An Elegant Weapon for a More Civilized Age." So this is me in a galaxy far, far away, and you can reach out to me practically. And I like lots of different things, but let's just talk about Closure. So what is Closure? It's a general purpose language used for a wide variety of applications, services, APIs, embedded control systems. I've seen people use it for. It's used by NASA as well. And pretty much anything you can use for it. So it's a general purpose language, just like all the other languages. It's designed to be a hosted language. So it uses the facilities as a host wherever relevant, and provides first-class interoperability in a very simple syntax as well. So you can use all the good things from Java, Kotlin, Scala, Jython, Haskell, Haskell-J, and all the other languages that run on the JVM. They're just a library away, really. And the Java Virtual Machine was the original host platform for Clojure, and it's still the largest used, especially when using like Graal support. So you can combine, you can compile natively your Clojure applications and run them as a native application. You can do that today. A lot of the tooling around Clojure is written in Clojure and just shipped as Graal binaries. And you can also run it on JavaScript platform as well. So there's the Clojure script language, and you can use that for websites. You can use that to run a whole range of the JavaScript ecosystem, running Node packages. You can do React Native, so you can do mobile development as well. So it's pretty much the same language. There's a few host limitations being on JavaScript, but apart from that, it's exactly the same language and syntax. You can even run it in .NET and build games with Unity, and even if you want to, you can even run it in Excel. So it's a pretty ubiquitous usage. And Clojure is Lisp, so it's quite different in the way you think about and structure and design your code. There are brackets, and we make no apologies for having brackets. They are a wonderful thing. And so Lisp stands for Lisp processing. So Clojure code is defined within a list, forming what we call an expression. And so the round brackets are there to kind of show the scope of your code. There's no semicolons to worry about losing, but you do need to make sure your brackets are balanced. But then there are editors that do that for you as well. And inside the list, the first element is always treated as a function call, and the rest of the elements are values that pass that function argument as well. And the values that we use as arguments can also be functions. So you can replace 4 by a function call to the plus function with 2 plus 2. And so that way you start going down the rabbit hole of functional composition. So the REPL is very central to working with Clojure. Basically, I always think of no REPL, no Clojure. It contains the live environment for you to interact with by sending it code, and it provides instant feedback to help you understand in detail what your code does as you write it. So you don't have to wait to understand what your code does. There's no visible compile, build, run cycle. You don't have to wait for that. You can instantly see what your code does, and we'll see an example of that very soon. And we can start a REPL UI in the terminal, giving a simple way to start interacting with a REPL. And so this is just a tool that runs on top of the Java command line. It's very simple, very lightweight, and very fast to start. And we can start by typing in expressions into the terminal, and the REPL will give us the results straight away. So here we're mapping the function inc over a collection of values, and it's going to return a new collection with new values. And if we want the full REPL experience, full Clojure development experience, then we use an editor, obviously, and there are quite a few different editors around there. So you can use IntelliJ, you can use Emacs, you can use Visual Studio Code, you can use Vim. All these tools, all these editors are supported very well, and code is written in the editor, and you can evaluate line by line the code expression by expression. You send that to the REPL, and you get the results. So here we're calling a function called toRNA with some argument, and we get the result straight away. We don't need to compile and build the code, and it allows a very flexible and dynamic interaction when you're developing things. You know exactly what your code is doing as you're writing it. How does that work underneath? Well, we take the source code and the things you type in at the REPL. It's read in by the Clojure reader as characters. This converts it to an abstract syntax tree, which isn't a lot of work because Clojure is actually already a data structure. It's a data structure that's a list. And so there's a little bit of macro goodness thrown in there as well, because we can write little kind of macro templates that expand into functions to extend the language a little bit. But most of the work we do is just writing functions and evaluating them. They're compiled into bytecode and it's all running on the JVM. And so it's very easy to run and deploy this just in a Java environment. You don't need anything special. You just need the Clojure standard library. And when we're exploring Clojure, then it is a very data-centric language. So as the projects grow in scale, then inspectors can be used to visualize data from the REPL, providing navigation for nested data structures and paging through very large data sets. So I've used this for doing some fairly basic data science, but there's a lot of people using some really interesting tools with Clojure to really explore very large data sets. And this helps the development team understand what the data they have and how they should be transforming it into be able to do the things that they want to achieve. And so understanding the shape of the data in the system is highly valuable, as most functions in Clojure are transforming data from one shape to another. This is the way. Let's have a brief glimpse of Clojure development in action. Hopefully I'm not going to overrun too much, but this is a video. It's online as well, so you can see the video and my explanation in a bit more detail. But essentially what we're doing is trying to find the most common word in a book. So we're slurping in the text of a book, and this creates a string, and we're binding that string to a name called importance of being earnest. And then we can use that throughout the rest of our code. And then we want to eliminate all the common English words, so otherwise we'll just have the and as the top of the list. So we slurp in some common English words that are in a comma separated value format, and we put them in a set so we get the unique words as a set, and we can use that to filter out those when we try and find out the most common words. Now in this function we've commented out some of the code, so we can actually see bit by bit how we built this function up. So we call the function, we pass the book into this reseek expression, which we run a regular expression over. And this is basically, this is using the threading macro, and it feeds in where the 3 commas are, the book, and it makes a complete expression, which is then passed on to the further ones. And you can see when we call that, it's generating a list of values and these which are individual strings. And then we lowercase all the strings to match with the common English words. And we can see now we've got rid of all the common English words. We've got rid of things like the. But now we can really start to understand how often the words are actually in the book. And so now we've got a hash map, which key value pairs. So the keys are the words and the values are how often the words are in the book. And we can sort those by the values, so how often they occur. And again, we've got a slightly different format of data structure. And if we reverse it, then we actually get our answer. We actually get the fact that we've got Jack as the most common word that isn't a common English word. And it's very quick to help us understand and explore that data structure by visualizing the results of each of those functions. That is the Clojure way. And just a very brief few words about functional programming. What's the point of it? We all experience complexity, and some try and model that complexity. Clojure really tries to engage it's like a simple approach, breaking down that complexity into simple building blocks, which are functions. So in Clojure, everything really is a function. And if you make pure functions, then it's so much easier to actually understand the larger system. So complexity can be easily hidden through encapsulation. And if you don't know what your functions do, if they're not deterministic, then it's extremely challenging to understand the whole system. And this is the idea of side causes and side effects that actually help drive confusion and complexity inside your program. Because if your functions are not just taking arguments and then returning a value, then it makes it much harder to actually reason about them. And here's a very simple example of a pure function enclosure. Essentially, we take the arguments and we use the arguments and we return a value. And that way we know exactly what this function does. And if we build a system from all these pure functions, then it's much easier. Again, to be pragmatic, there's occasions where you do need to kind of do have side effects. You do need to change the world at some point. But in the main, Clojure is using immutable data structures, and so you're using list, vector, hash map, and set. These are the tools you use for modeling, and these are all immutable. And you simply make new copies of values when you apply functions over them. And you can use, and so Clojure uses this idea of persistent data structures, which when you actually run a function over a list or a vector, it's actually creating a new copy. But if there are any shared values between the two, then they're shared within memory, so you're not using any extra space. And this saves an awful lot of so this structural sharing is highly effective for large data sets and can be transformed a great many times without impacting on performance of your application. And then once things are no longer referenced, they're just simply tidied away. And if you do need to change state, then, well, it's there is a simple way to manage that: software transactional memory. It's like having a little database, an atomic database inside your application, which controls changing shared mutable state. And for example, here we've got the atom, which is a common tool to use for that. And this is a mutable container that wraps immutable data. So the value inside the atom is still immutable; it can't change. But you're basically swapping in and out new values in a controlled way, and you can only do that. So the software transactional memory manages that so that only one value can be updated at once. So it avoids having lock issues and race conditions and things like that. So in a nutshell, kind of functional programming is about eliminating the side effects where you can and controlling them when you can't. And I think Clojure does a very good job at managing that. And just to wrap up, there's lots of help on the community. There's a very great, vibrant community in the Slack channels and the Zulip chat. And there's plenty of websites there to help you get into Clojure. And there's also lots of books to read, far too many books to read on Clojure now. And just to add to that, I'm also writing my own at Practically as well. Thank you very much.
I trust on you to put in a GIF at the end there. Thank you, John. For some reason, I can't toggle your video back on, but thank you very much for your time there. Yeah, if you're looking at kind of practicality, some really interesting stuff on there that John frequently posts. I believe you post every weekend on YouTube. Is that correct? Or are you slowing down?
I only stop when I've got when I'm coughing so much it's intolerable to listen to me.
Okay, I'd rather that not happen on a YouTube video, but that's great. But no, thank you very much. What we're going to do is we are going to get everyone back up. So just close your video. Oh, I can see you all of a sudden. Where have you come from? Right then, let me just invite everyone else back on the screen now. Hopefully, guys, you enjoyed each of the chats. I like the kind of different approaches. We didn't set any guidelines, really, just let them run with what they feel is going to best kind of represent their chosen language. So just getting everyone back on screen now. And we're just going to answer some questions. I believe we got quite a popular question from Luis Santos, which got quite a lot of upvotes. So I think it's best to spend some time, certainly, on that one. I'm not sure, guys, if you can see the questions as well yourself. You can take a little look. If not, I can read them out. No worries. Here comes Ben. Adam, if yours is not coming through, the good old reload and go is always quite good. Okay. So, guys, thank you very much. Any further questions now, please get them in. On your polls, where we're standing at the moment, we're not quite there yet, but Closures is ahead, Scala in second, Kotlin in third, Java in fourth. Honestly, we hosted one of these events back in October, about a year ago now, and flip. So I'm not sure if there was the speakers. I don't think it was at all, because I know that Juliano, who was the Kotlin speaker back then, the Closure speaker back then, is in the chat. So I'm not disregarding that at all. But yeah, so what we got? I just want to kick off the kind of first questions. We got 9 upvotes now. So how do you see the feature of Kotlin now that Java is starting to introduce similar features? So obviously, I think I'm going to come straight to you first, David. It feels like Kotlin is loosening its uniqueness in the JVM ecosystem.
I wouldn't say that, actually. I'd say that, yes, it's great that Java's getting those features. It's been a long time coming. And I think it's something I think it's definitely better now than the bad old days. But yeah, so I mean, the thing about Kotlin, on the JVM, let's talk about JVM, is that obviously as Java gets those features, so for instance, records coming out Java 14, which is effectively the same as Davies classes, the Kotlin compiler basically becomes simpler, because it basically it doesn't have to synthesize those features in order to actually it can just use what's ever there in the first place. So actually, perversely, that kind of helps the compilation speed and the complexity of the Kotlin compiler. But I think it's to do with velocity of going forward. I mean, it's just, I think, especially, I mean, I'm not sure now, we'll see how records goes. I think there have been several features of Java that have been done badly. Optional type, for a start, is a bit of, if you ask any kind of functional program, they'll tell you it's basically a travesty. The Streams API it's not great, to be honest. It's missing. It's modeled in a way that they obsessed about getting the parallelism working exactly the same way as non-parallelism, and that's had an effect on the API, which has actually made some things actually almost virtually impossible to do, like a fold, which is a standard kind of type of functional kind of like construct that you use. So no, it's great that Java's getting this stuff. It's brilliant. It just makes everything better. I'm not, in the times where you need to actually go into a project, being an independent and so on, I don't always get to use what I want. Yeah. So I would prefer to use a better language than a worse language. So that's perfectly fine.
Nice answer. I think again, we're going to keep that positivity there towards that. We don't want to be battling people down, but it seems like any advances in any languages, whether it's new features, new versions, come on board, go for it. Let's make everyone's lives a bit easier. Anyone else want to kind of contribute to that? I think David answered that pretty well myself. But
yeah, I guess one thing I would add is that Kotlin really has a lot of other features that I was mentioning, like coroutines, for example, right, which are way ahead of what's in Java, maybe in Project Loom, but we will see really. And well, this applies really to any language that any JVM language has the liberty to innovate at a much faster pace than Java. Java is already much faster than before, like when we were waiting for Java 6, 7, 8, well, this took years. Now there's a release every half a year, so that's much better. But it's still a slow process, right? And let's say these alternative languages have a much higher chance to actually innovate, partly because they are not that popular, right? So Java is, in that sense, a victim of its own success, right? So Scala can make the leap from Scala 2 to Scala 3, which is a major change, and Java wouldn't be able to do so much changes, I guess.
It's the same way as things.
That's just evolution, right?
It is the same thing though, because my other thing that I do, of course, is C++, and that won't change for love nor money, and hasn't for the last age. And that's kind of the point about Java is although it is evolving, and the best thing about having other languages on the JVM is it's forcing evolution, and it's kind of driving forward this kind of base infrastructure layer of it's almost like a feature gets proven everywhere else and then comes to Java, even if it comes in a roundabout way. To build up on what David said, yes, the streams are great for what they are, but they are definitely not complete, and they make most Haskell programmers go, "Are you sure you know what you're talking about?" Whereas I'm going, "Yeah, it's great. At least I don't have to deal with all that nonsense anymore." And they're like, "Are you sure?" I'm like, "It's still good, still better than what we had."
Yeah, exactly. You always look back. Grateful for the different versions, different adaptations to it. But on the kind of more, it seems like more of a comedic thing here now. So if not your JVM language, or if not Java, Scala, Kotlin, or Clojure, what would you choose? Let's go with John. Outside of those 4 languages, anything you've had exposure to that you think you would use?
Well, I think the thing that comes to memory was I spent an evening at Skills Matter, which turned into be a very long evening, but really an interesting evening, where somebody was talking about implementing Haskell on the JVM, like pure Haskell. And that was fascinating. And I think Haskell was the language that got me into functional programming, even though I don't actually use it. I think that would be a kind of fascinating experience, because you don't always want a language just to be productive. Sometimes you want a language to learn as well. And I think that attracted me to Scala at first, because there were so many different concepts for me to sink my teeth into. And so definitely, Haskell, and you can still do quite a lot with Python if you're doing data science as well, although there's really nice bridges between Clojure and Python now as well. So you can pick your weapons about which language you need to do for data science. Nice. But yeah, Haskell, well, I'll go for Haskell.
Haskell, we got Haskell. So David, I'm just going in order on my screen here.
Okay, yeah. So I would say Rust, but I'm not. It's not something I've used enough. So I'd probably say TypeScript, just because it's doing a great job of making sense of JavaScript.
Is this going down a different rabbit hole with JavaScript? Shall I stop?
No. Anyway, I'll leave it there.
Ben, anything you kind of would like to work with, or thought it quite
For
interesting?
me, I suppose it's Zig, or Ziglang, as it seems to be known these days. Zig came out of the idea of, the only real problems with C are that there's a preprocessor and we can't run it at compile time. So it comes down to a language where there is zero hidden control flow. Allocators have to be explicitly defined as you go along. And because it's all LLVM based anyway, it compiles unbelievably fast, allows you to do things like bit twiddles in line with no extra work. And it has such a kind of focus on correctness. Not the same way Rust does with borrow check and everything else, but with the idea of being, what you're doing with memory, you know why you're there, and you know what you're trying to express at any given point, but still maintaining this kind of full compile time, almost S expression type approach of just generating the types you need, generating the code you need, and doing it very explicitly.
Sweet, that's one that, I'm going to be totally oblivious here, never heard of, so
it's
I'm going to have to do my research. Okay, I was like,
no,
I thought I knew my stuff a little bit, but I was like,
it's a year and a half old, but the community is thriving because of the number of, C devs who are tired and bored of annoying problems.
Right. And Adam, quickly before we move on to we can actually move on to a quick Scala-based question, which is in the chat.
I was going to say Rust as well, because I really like the idea of having all the performance that the computer gives me. I don't like the idea of having to control the memory always that much, but I guess I'm going to say Unison, which is a language I want to play with when I have some time, for quite a long time now. Unison is a language for distributed computing. It's a functional language, inspired by Haskell, inspired by Scala. Really interesting one. It does away with the notion that program is represented as text. because you've got function hashes which are independent of names and so on. So I think Unison might be really interesting, even if it doesn't succeed commercially, just to see how the ideas there work out. So that would be my bet.
Cool. I know it's slightly off the topic here, but yeah, it's just a question we had, and that was quite interesting to see, yeah, if it's something you've explored in the past. But we've got a couple of votes. Kui, sorry if your name's totally wrong there, but how does Scala handle memory consumption when dealing with immutable data structures? I mean, does it copy the whole thing round? It seems like there's a little bit of a debate on the chat already, but yeah.
Yeah, so I think it does a similar thing as mentioned in the closure. So there is structural sharing. The whole collection library has been recently rewritten in 2.13, so that's the latest general availability release. So you don't see that much of an effect of the immutable data structures. I would say it's again very similar as in a closure. Of course, there is some overhead, but it's not as big to be noticeable unless you've got a really critical section. But then if you have that critical section that you really need to optimize, you always have the fallback to going to mutable data structures and mutable programming. But that tends to be very small and localized. So in my experience, it's not an issue.
Cool. Thank you. I'm just having a little browse through. I'm not sure if you can see the questions there, guys, and if there's anything you kind of thought would be worth asking. We got some what happened to Groovy. Why the Java collection seems to look like designed by a 6-year-old. So I'm not sure if that's I think Roman's come up with both of those questions. Yeah, and is there any of those?
I wouldn't say so. Java collections are really successful, like given how long we've been using them. I mean, well, they are mutable, but that was the way you wrote software back then. And as a mutable collection interface, I guess they have proven to be really robust, and they have their weaknesses, but overall, I guess they have proved their worth.
I'd be interested to see what Roman is using or what his passion is, because he does not like Java. You constantly have to use additional libraries like Apache Commons, sad face, with a wink. This is quite contrasting there.
Ben, you are muted. I think you're trying to say something.
You're muted.
Okay, no, it's like to go deeper than that though. It's like you always have to use additional libraries, but the trick here is they exist, and that's kind of the thing though. Like having a small standard library doesn't restrict you too much in a lot of ways. It just means that you end up like it forces developers to specialize. And particularly things like Apache Commons, they work, and particularly the Java stuff. Also, the collections work pretty well. It's like mutability is often bashed, but the world and memory is mutable at a very kind of finite state. Immutability is a great construct at compile time, but when you hit runtime, as long as you've proven correctness already, it does get in the way of true performance at a certain point, as effectively you are still having to walk addresses at some point.
And I wouldn't actually call the Java standard library small.
No. So yes, I admit that. Like small is the wrong word. Yes, extensive
it's
yet
not even
weird.
bijou. I think that's one of the. I started with Java back in 97. Oh my god, I'm showing how old I am. And one of the biggest advantages of Java was the standard library. It made it so much easier to use than C++ and C. It was just like an absolutely no-brainer, and that's one of the reasons why it took off. It's just because you could actually use the library, you could actually use the language without having to like buy commercial packages, buy commercial libraries, and
or roll your own hash tables, which is something I've done more than I should have.
Yeah. And the huge amount of open source that grew around Java as well, I think that was a massive success. I mean, from like the end of the 2000s all the way up through, it really kind of was the one thing that did attract it. It was the ecosystem around Java that really kind of built it, and without that, then we wouldn't be here talking about all the other languages without Java. So we do owe a debt of gratitude for everybody that contributed to Java right from the start. and made not just excellent libraries but excellent tools, like people would using JUnit and so on, to actually make a really pleasant and enjoyable development environment for people. And we've just keep on building that, and it's, I think, like around 2007, 2008, they just started all these new languages appearing or in people's radar as well, and we've just built on the kind of success that Java has given us.
Awesome. I'm a little bit cautious of time, just because I don't want to keep people here forever. But I think we got a question here, got a couple of votes. So we're looking at kind of Scala 2 versus Scala 3, backward compatibility, or problems like Python 2 to Python 3 with adoption.
Yeah, this always comes up. Yeah, of course. So I guess Scala is in a slightly better position than Python for a couple of reasons. First of all, we've got the Python experience, so we know what to avoid. Second of all, it is a typed language, so this and helps to guide the migration. You will have to recompile all of your code to run on Scala 3, but then because of the types, you will get much more feedback from the compiler. And finally, I think the changes in Scala 3 are not as fundamental as in Python. So if I'm correct, I think the string representation changed or something like that. So these changes, they are quite significant, but most of the old code will still compile. So I think I hope, well, we'll see, of course, how it goes, that we are in quite a good position migration-wise.
Cool. Hope that helps out. So we're just gonna got loads of questions coming through in the chat, which is nice and healthy. But just gonna quickly check in on the polls. I hate to have a draw. It's like American football. You can't have a draw. So, Adam, I think you need to fly over to London, have a physical fight with John. No offense, Adam, I do think John's got that. I think he's got
John
a physical
can come to
fight.
Warsaw as well, right?
Okay, then, okay. Let's make it even. Straight off the flight to Warsaw. But,
just not at the same time, because then we will
you don't want a physical fight. But, guys, I think, really appreciate your time. It's been about an hour and 15 minutes now. If you've got anything you really want to add, John, is there anything you want to plug before I kind of do my finish up stuff?
No, I'd just like to say, I hope you liked what I said about Clojure. I hope it gives you some incentive to go and try it. I think if you try it for a couple of weeks, you'll love it. And if you don't, come and ask me and I'll help you love it. And there's a great community there to support you if you want to learn how to do it. Like, drop into the Slack and ask lots of questions, and it's a really friendly community. They'll help you with anything Clojure related, obviously.
Cool. I'd love to provide through our Orbis Connect channel any links that's going to really help people connect together from any of these now. So we'll put a post up on our LinkedIn soon after this that you can connect. So David, anything you want to plug?
Nothing I want to plug really. I mean, it's worth actually interesting. I'm missing currently there's a Kotlin 1.4 event actually going right now, I think. I think anyone who's watching this should learn all of these languages and then decide for themselves which they like. They shouldn't just do one.
Nice, like it. Ben, anything you want to plug?
Not so much, other than just to say, like a bit like what David just said, is like, these things all have their kind of domain, which is amazing, right? And like they all kind of can do more or less the same thing, but they're all something that they're really, really good at. If you know your domain, try and find what fits, as you're always going to be building on the shoulders of giants. So never just like take it as read that you must use, C++ for games, or you must use Python for data science. Everything is game in almost every language, as long as you can find the support for it.
Nice, like it. Adam, last words before I close this up.
Yeah, I guess whatever language you'll end up using, I think it might be a good idea to at least try and look at functional programming as a way of writing and structuring software, be it in Clojure, Kotlin, Java, Scala, or whatever other language. I think it is a better way to write software in many cases. So if someone hasn't explored it yet, I guess I would encourage people to try. And yeah, if in case of any questions, my DMs on Twitter are open, and it's quite easy to find me on the internet as well. So,
nice. Yeah, I just want to say thank you for your time, and obviously everyone who's in this chat. A really good turnout, good interaction. Seems like they really enjoyed the conversation. So yeah, thank you so much. Before I literally log off now, let's look at the polls. And someone's putting a little sneaky vote for Clojure at the end. So I think in the chat here, people have asked about recordings. There'll be a recording put up on our LinkedIn channel. Guys, all I request is you send me any links that you want. Yeah, any questions, please ask away. I'm sure these guys are open to hearing about you and hearing from you, from whether that's LinkedIn, whether that's Twitter. Sorry to put you out in the limelight there, but people might reach out to you. So again, in the information tab at the top, if you click on that, it's just a whole overview of the whole event where you've got every kind of social media link. My name's Aaron Shakeshaft, the weirdest last name you might ever hear. Or you can call me Shaky. And yeah, thank you very much for your time, guys. We'll leave it here.
Thanks, Aaron.
Right. No worries.
thank you.
Take care, bye.
Have a good
Awesome.
evening.
Thank you very much. Have a good evening.
Week.
26. 26. 26.
Doing well.
Cheers, guys. Bye now.